Welcome everyone to the Queensland Battery Booster Industry Insights webinar. I'm thrilled to see so many of you joining us here today. As many of you might know, GSES ran the Inspectorate program for the Queensland Battery Booster from mid-2024 to mid-2025, and the results are in, and we're excited to share them here with you today. In this presentation, we'll dive into the inspection outcomes, technical findings, and some recommendations for installers and the industry. I'm Chris Martell. I'm the Managing Director of GSES, and joining me here today is Fernanda Oliveira, who is the Operations Manager for our consultancy business at GSES. Fernanda managed the Queensland Battery Booster inspections from inception until project close, and Fernanda is certainly the best place to take you through the metrics captured and the insights gleaned from this very important program. I also have here with us Patrick Isa, who will be the host of our webinar. I'd like to take a minute just to introduce our business in order to provide some context for this presentation. First, I would like to introduce our sister company, Mindaro. Mindaro is a commercial and utility scale design firm with deep engineering expertise and industry experience. This group provides engineering support for construction for many of the leading Australian and international EPCs. If anyone in this webinar is looking to develop, own, or construct large-scale renewable assets, I would recommend they get in touch with Mindaro for support. Next is our new venture, Diagno Energy. Diagno is a consumer energy resources intelligence engine that uses machine learning to deliver natural language diagnostics in order to drive system safety, performance, and service fulfillment. The Diagno team is currently working through a Race 2030 project with the University of New South Wales and UTS. The work they are doing is very exciting, and equally, the issues they are uncovering are very surprising. I would encourage you all to watch this space as Diagno continues to develop and scale. Next is GSES's training business. GSES training is likely what we are to be best known for, as we've provided training and capacity building services since 1998. The GSES training business is a specialty business focusing only on renewable energy. We author and manage our own content, which we also provide to other RTOs and training institutions in Australia and around the world, focusing mainly on the Pacific Islands, Southeast Asia, India, and parts of Africa. Finally, and most relevant to this presentation, is our consulting business, which offers strategic procurement and management services for solar, BESS, and EV charging infrastructure, mostly for state and local government entities. This group has also been conducting system inspections for the Clean Energy Regulator and other stakeholders for over 15 years, having conducted well over 25,000 inspections across the country and overseas. The various domain expertise of the business groups makes us uniquely placed to provide a comprehensive inspection service, as well as the desired industry uplift. The work that the team has done for the Queensland Battery Booster inspections was executed with a deep level of care and pride, and I am incredibly proud of everyone that has contributed to this project over the past year. For the webinar agenda, first, I will be providing some program context, and then Fernanda will take over and show you through reporting metrics, compliance data, and unsafe findings. I will then take you through a few case studies before I hand back over to Fernanda to go through some final industry recommendations. Again, at the end, we will attempt to answer as many questions as possible, but if we miss your questions, please feel free to get in touch with us directly. Next, I'd like to lay down some context for the Queensland Battery Booster Program and why we feel that it was so important. The Queensland Battery Booster Program was launched ahead of other significant government incentive programs, including the federal government's Cheaper Home Battery Program, which has, in its first 12 weeks, delivered 55,000 batteries, representing over 1 gigawatt hour of capacity. Queensland Battery Booster, in its own right, delivered 35 megawatt hours of capacity, proving the success of a best incentive program to be delivered at scale and to a targeted segment of the community. The program was designed with a bold and practical delivery framework. With clear consumer safeguards and mandatory inspections, we feel that the Queensland Battery Booster Program is a model for how state and federal programs can drive both uptake and confidence in emerging technologies. The program also delivered industry uplift through accountability by encouraging rectifications, mandating higher quality installation practices, and engaging directly with contractors. As a result, the program has elevated installation quality and consumer outcomes across Queensland. Finally, the program included a focus on training, QA processes, and industry engagement, which ensured that the benefits extend beyond individual installations, strengthening the resilience and professionalism of Queensland's renewable energy sector. As an example, GSES delivered 25 face-to-face industry training sessions with both SIA and solar cutters, where the training was directly informed by outcomes from the Queensland Battery Booster Project. We would like to thank the Queensland Government for the approach that they have taken and the highly collaborative working relationship we had. And I would also like to thank our Queensland inspectors and the Queensland Electrical Safety Office for working with us to get the right outcomes. Here's a quick overview of the program structure. So at the outset, eligible homeowners could apply for the rebate, and assuming they met the technical and means tested criteria, they would become conditionally approved. Next, the system would be installed by the preferred installation company, and upon sign-off, the rebate would be released. GSES would then conduct the inspection and provide the installer with an initial report. The installer was given 14 days to provide comments back to the report and, where required, rectify issues and provide evidence. Finally, GSES would reassess the system and send a final report to the installer and the homeowner. Here is an overview of the program. So prior to the contract award, we were informed that there may be up to 3,200 rebates provided. By the end of the program, there was 2,854 rebates approved, which is nearly 90% of the stated goal. GSES was then able to inspect 2,773 systems, or over 97% of the possible total. The ones that we missed all had some practical reason why it was not possible, such as the homeowner moved, or there was a legitimate personal or medical reason to decline the inspection. The program approved 558 installation companies, and 362 of them installed at least one system. The largest number of installs from a single company was 148, and it should be noted that that company was also one of the highest quality installers, which is a great outcome for the program and the state. About 80% of the inspections were conducted in Southeast Queensland. However, inspections were conducted as far and wide as Quilpie, Queensland. GSES was able to provide a cost-effective and efficient inspection service through 24 vetted inspection service providers, as well as a back-to-base reporting process using digital data collection tools and associated data reduction and analysis scripts and methodologies. So let's delve into some of the specifics of the program and some of the superlatives. The program had a minimum PV system size requirement of 5 kilowatt of solar, whether it was existing or newly installed alongside the battery. Notably, 47% of these installations featured brand new solar systems, which is a significant proportion. 99% of the systems that attracted the rebate were grid connected and are used primarily for self-consumption and retail arbitrage. However, we did have 31 sites which were installed off-grid. When it comes to battery systems, 76% of the installations feature hybrid inverters with pre-assembled Section 5 batteries. Meanwhile, 20% utilize AC batteries, which are pre-assembled and integrated as per Section 4 of the AS/NZS 5139. Furthermore, over 60% of the sites had a total combined inverter capacity of less than 10 kVA. This indicates the varying scale of installations catering to different energy needs and site capabilities. This also had implications for the installation of the Queensland Grid Signaling Device, or GSD. I will now hand over to Fernanda, who will discuss the program structure, reporting metrics, and some outcomes.
Thank you, Chris, and welcome everyone to the webinar. We have a lot of data to go through, and we chose a few of the most important bits. So I want to start by explaining our prioritization method for the inspections. In our prioritization method, each system inspected received a normalized rating. This was based on compliance with each clause of our comprehensive checklist. This rating plays a crucial role in our operations by identifying which sites presented a higher risk, and those higher risk sites were then prioritized for inspections that ensured that our resources were focused and where they were needed the most. This point system reflects a risk-weighted ordinal model that follows a logarithm scale of severity, and is informed of risk weightings derived from our other historical inspections and generally aligns with ISO 31000. And that one is the risk assessment matrices, where risk increases geometrically with consequent severity. The inspection was focused on the compliance of the battery system itself installed in each site and included all the base equipment, the inverter, and the switchboard. However, we also did a safety check for all the solar systems on site, so that included going onto the roof and checking the panels. Each system was rated at the end of the inspection by the number of non-compliances it received and how severe they were. So if the system had no issues at all, the system was tagged as best practice, very minor issues, generally compliant, a few issues, adequate, and system that had performance issues or issues that will degrade the system over time, those were marked as substandard. Finally, if anything was found as an immediate risk to people or to equipment, it was directly set as unsafe and was isolated and reported as per our unsafe procedure. So let's discuss a bit of the inspection outcomes. These are the outcomes given to a site based on the number and severity of the non-compliances. Our inspections revealed a nearly equal distribution of sites were compliant, adequate, and substandard, with slightly more substandard sites. About 2% of the sites were identified as unsafe, and we'll talk about those in detail later in the webinar. As Chris mentioned, all the installers had a chance to rectify issues and send us comments and proof of rectification. We received proof of rectification or comments or justifications for about 28% of the sites, and this process of review and improvement was essential for achieving high compliance standards and also to uplift the industry through educating the installers on the requirements. The most positive outcome here is that over 40% of the sites were finalized as compliant after all these efforts, and we had even 25 sites being finalized as best practice. We also saw a significant decrease of unsafe sites. This graph gives us a visual representation of the shift from initial inspection outcome to post-rectification outcome. We can clearly see that most of the non-compliant sites, including the substandard, adequate, and even the unsafe sites, were improved to compliant and best practice afterwards. You can clearly see all the lines going up towards best practice and compliance. I want also to show the proportion of each compliance rating through the months of the program. In the left-hand side, you can see the initial inspection outcome and how substandard proportion increases over time. That's mostly due to our prioritization method, which led to us targeting more and more substandard sites as time went on. In the right-hand side graph, we have the post-rectification proportion, and you can see that the compliant rates actually decrease over time. This is mostly due to the program not having any repercussion to non-compliant installations. That means that the installers did not get penalized for substandard installations. Eventually, that led to less installers rectifying issues towards the end of the program. Now we'll jump into the outcomes for the different site variables. The first two ways we can classify the sites are brand new PV installations with the battery system versus existing PV installations or retrofitted systems, and we can also classify them in grid connected versus off-grid sites. The compliance rates for the new, that's the orange bar, versus the existing, the light blue bar, were pretty much the same. This indicates that installing a new solar system did not directly affect compliance of the battery system. Next, I'll draw your attention to the grid, that's dark blue, versus the off-grid, that's the purple, where there is a higher proportion of off-grid compliance outcomes, but also a higher proportion of unsafes, which may indicate that off-grid tends to attract more specialized or experienced contractors. However, system complexity can, in some cases, drive negative outcomes. Another interesting subgroup was the different types of battery and inverter connection. We split the batteries into three categories. The first one was AC batteries, that's your pre-assembled integrated or your Section 4 batteries. The second one is your hybrid integrated. Sometimes they're classified as pre-assembled, sometimes they're classified as pre-assembled integrated, but they are your typical all-in-one package where you can build up with modular batteries. And finally, you have the hybrid inverters or pre-assembled batteries. That's your Section 5 of AS and ZS 5139. These are the battery inverter sets that require all connections between battery and inverter to be done by the installer instead of coming in a single package system. We found that most of the batteries installed in this last category, so the battery separate from the inverter, were 76% of the batteries installed in the program. However, we saw a higher compliance rate with the AC batteries, so the pre-assembled integrated, possibly because the battery is simpler to install, as the connection between battery and inverter isn't done by the installer themselves. We can go even in more detail onto this data by checking the different OEMs and where installers have more non-compliances. In this graph, we de-identified all the batteries, but you can see the first three are pre-assembled integrated, while the other ones are pre-assembled batteries. We grouped all the checklist items into 8 logical groupings, representing areas of the installations. So you have battery, battery and inverter, hybrid inverter, PV inverter, meter board, rooftop solar, etc. When looking at the clauses for the sites that had AC batteries, the pre-assembled integrated, Section 4 batteries, we see a larger non-compliance rating towards the PV inverter and the roof, which most likely were existing systems and not installed with the battery at all. It is also interesting to note that the pre-assembled or the Section 5 batteries typically had not more non-compliances for the hybrid inverter and not for the battery itself. This leads us to conclude that the battery itself is not difficult to install, but the higher complexity that the battery installation brings, the more installers struggle to get the full system to be compliant. Now we'll shift the topic a little bit to installation companies. We had 362 companies installing at least one solar system under the program. Many of them installed only one or two, but some installed over 100 systems. To have a better understanding of compliance ratings by companies, we picked only companies with 30 or more installations, and we ranked them using our prioritization method. And the ranking is not displayed here, but you can see how they were ranked. The best performing company installed 30 sites and only had 2 of them being substandard. But the third place was the most intriguing one. This company had the largest number of installations under the program and still only got a 15% substandard site rating and only 1 unsafe site. Now, when we look at the bottle fill, we have a very different scenario. The number of sites installed is similar to the best ones, but now the percentage of substandards goes up significantly. These companies are ranked by the number of non-compliances on their system, meaning that the installation had several issues in different parts of the systems, and that's what made the system substandard. If we have a look at 5+ installations, so a lot smaller scale, we find that the percentage of substandards and unsafe sites go up by quite a lot. This table was ranking the percentage of substandard sites after proof of rectification was received or after the rectification period finished for installers with at least 5 installations. We see that many of these companies did not rectify the system after the inspection, which is different than the large companies that put a little bit more effort on the rectification process. The rectification process shows to be essential when handling inspections. Now I want to talk about the non-compliances found in the actual reports. Consistently, the minor non-compliances involved issues with labeling. Although this might seem minor, they can lead to confusion and errors down the line or to other workers on site. It is essential to ensure the labels are clear and accurate and make sense to anyone else looking at that system. Moving to median non-compliances, we see recurring issues with both labeling and documentation. Additionally, there were problems with the solar array frames and so on. These issues started to show more significant implications on functionality and safety of the system. Finally, the major non-compliances. These are critical and include problems like improper inverter and battery earthing, failure to follow the manufacturer's instructions, and those issues can actually pose serious performance risks for the system and can show later degrading of the system. And the program highlighted 3 sites with alarming signs of fires or burn marks. One was inside the switchboard. We actually saw quite a few arcing switchboards. This one actually had burned cables. 2 were isolator fires, so existing system fires. One of them was right next to the battery, but then the battery got relocated next to a gas bottle, so it remained as an unsafe system. From September onwards, our prioritization of high-risk sites revealed an increase in the number of unsafe sites. This indicates that the priority matrix was working well, so we were able to capture more of those unsafe sites earlier on. You can see that it flattens out closer to May, which means that we didn't find as many unsafe sites in the end of the program. The largest amount of unsafe site issues were actually not with the battery, but were in the switchboard. Then we had battery issues in second place, followed by legacy PV systems, which is things like water in the rooftop or broken modules. The unsafe sites were immediate risks to people or equipment, or when a fault could lead to a catastrophic outcome. We tagged unsafe sites, water ingress into isolators or other electrical equipment, damaged equipment that is not isolated, such as damaged panel, damaged battery, etc. Overheating equipment, so we did thermal scans of all the equipment. Anything that could cause electrical shocks, such as exposed live parts. Battery installed very close to gas bottle due to the catastrophic outcome. And systems that did not have overcurrent protection. That's a few of the situations that we had. There were a lot more. And every time we had an unsafe issue, we would come together as a team and make sure that we all agreed on the level of unsafe and severity of the issue. Now a little bit about the unsafe clauses that were most frequently appearing. The first one, the one that we had the most, I think we had about 25% of this, was loose connections in system cables. Then we had lack of incorrect earthing for the PV array frame or modules. We have the inverter not installed to manufacturer instructions, so that could mean RSDs were not installed, was a homeowner installation, and so on. Then the AC output of the inverter incorrectly connected to the MEN on the neutral bar. We'll talk about this one in more detail on the case studies. Exposed live parts. This was about, I think, 10%, 12%. The battery being incorrectly earthed, so DVC-C batteries not being earthed at all, and batteries not installed to manufacturer's instructions. So that could be the battery not secured properly, high risk of breaking, high risk of failing overall. Now I'll pass it back to Chris for some insights on those gray areas of the standards and inspections.
Thanks, Fernanda. During our inspections, we have found that many installers are not earthing the inverter frame or the battery frame correctly or at all. Initial discussions with the Electrical Safety Office and other key industry stakeholders considered deeming this issue as unsafe. However, since there is an earth connection through the AC earth, it was only considered as substandard. The frequency of an issue resulting from this improper earthing would be very low, but the consequence could be very high. The protection class, DVC, and configuration of the system matters to how the earthing of exposed conductive metal parts is done. However, generally speaking, the external earth lugs provided by the OEM should be used. We're showing a picture of what those external earthing lugs look like. Earthing of exposed conductive metal parts is discussed throughout AS3000, and most OEM installation guides call out how and when to use these earthing systems. Thankfully, this is quite an easy and inexpensive fix, but it's actually very important that this is done correctly going forward. In our next case study, we show here something that we're hopefully all familiar with, which is how AS/NZS 5139 defines a habitable room and where a BESS can and cannot be installed. Various training providers and industry associations have done a good job educating the industry on this point. However, during our inspections, we did find a few situations where liberties were taken with these definitions. It is important for the installer to understand the intent or spirit of the standard, which is ultimately to protect personnel and property. The example that we're showing here is a garage, which is deemed not to be a habitable room, which has been converted into an entertainment space. Making this change means that this is now considered a habitable room, and a BESS can no longer be installed here. We appreciate that there might be some gray areas to this, but again, the intent or spirit of the standard must be understood, and a reasonable and rational approach should be taken by the installer. The third interesting non-compliance we found was with the connection to the neutral, as Fernanda mentioned previously, as it depends on the different battery and inverter manufacturers. There are three common configurations that you might encounter. In the first configuration, There's no internal neutral connection. Here, the neutral is not connected inside the inverter, and it's very important to ensure that an external connection is made. In the second example in the middle, a neutral bridge is internally wired by the OEM. In this setup, the original equipment manufacturer has internally bridged the neutral. This can simplify installation, but requires verification within each installation done. In the third example on the right, the neutral is switched internally. This means that the inverter itself manages the switching of the neutral connection. Understanding this functionality is essential for both ensuring proper operation in the grid, in grid tie and backup modes. This often requires external neutral bridging to be made by the installer, and you should be checking with the OEM installation guides. Each of these configurations affects how you should approach installation, as well as testing and commissioning. Always check the specific inverter's manual and manufacturer guidance to avoid errors and ensure neutral continuity in various modes, and especially during your commissioning and testing. Now I'll hand it back over to Fernanda, who will discuss some key industry recommendations.
Thanks, Chris. The data led us to two main conclusions when it comes to the non-compliance and unsafe systems. Firstly, that many installers are simply not up to date with the Australian standards requirements, and this isn't just about awareness. The frequent updates to these standards and industry guidelines can create a considerable confusion. Moreover, the standards are notoriously complex and can be costly and time-consuming to fully grasp. Even manufacturers sometimes find the requirements unclear, and that speaks volumes about the challenges installers are facing. There is also the commercial pressure. Jobs need to be done quickly and cost-effectively, and this often leads to corners being cut, like skipping crucial upgrades to the switchboards or neglecting proper cable management. Ultimately, these factors culminate into non-compliant installations, such as loose cables in the switchboard, and understanding these challenges is essential as we move forward to discuss our program recommendations. Now let's explore some recommendations to help the installers to navigate the complexities of standards and regulations more effectively. First, it is crucial to pay extra attention to manufacturers' installations guides. They provide the detailed information needed to ensure aspects of the installation are properly covered. Second, staying current with changes in standards and regulations is key. You can do this by engaging with RTOs like ourselves, attending conferences, subscribing to industry newsletters. This continuous learning helps you to stay ahead. Next, refreshing your knowledge on electrical standards like AS 3000, 3008. Doing that regularly will help you maintain a high level of compliance and expertise. And additionally, view industry and regulatory inspections as valuable learning opportunities. As GSES, we're always here to help, and we'll help you explain any non-compliances we find, and we can turn this into a chance for growth and improvement. Finally, consider offering maintenance or follow-up services to your clients. This ensures ongoing safety and satisfaction and can prevent issues from arising after the installation is complete. Finally, working with the Queensland government gave us some insights on regulatory bodies, and here are some recommendations for the industry. This program itself was mostly about industry uplift and less about the formality of things, which was really good. But first, inspections, they're not just a formality. They're a key part of improving system compliance and safety, especially for larger installations or when there is a rebate available. Next, consider the rectification system. It's crucial that the system is easy to navigate and serves as a tool for learning and improvement. By ensuring that this process is not burdensome to the installer, we can empower installers to enhance their skills and knowledge and improve system compliance this way. Finally, there is a need for more educational content. By providing clearer and more accessible education resources, we can uplift the quality of installations across the board. This goes hand in hand with the need for more clear regulation and standards. And if these are easier to understand, then compliance and safety ratings will naturally improve. And just to give you a little bit of a bonus here, if you're looking at getting CPD points or additional accreditation training, educational resources, Please feel free to reach out to our training team by emailing training@gses.com.au or giving us a call. They have a new training course. It's available it's available now. It is a vocational course, so you get VET, but it also gives you 100 CPD points. For inspections, feasibility, consultancy work, please feel free to reach out to myself or the team consultancy@gses.com.au. We will try our best on answering questions and helping out. We're also available for this type of work. I will pass back on to Chris for some final remarks.
Yeah, I just wanted to say thank you to everyone for joining here today. I just want to open it up to the Q&A session. So I'll invite Patrick to come on the screen and go through some of the favorite questions that he found here today.
Thank you for that, Chris. Hello, everybody. One of the most repeated questions that we received is they're asking when will the video be posted or this recording be posted. It will be posted in the next few days after we do some minor editing. It might be released on our YouTube page and on our website. So please stay up to date with all our socials so that you can be notified of when that's uploaded. I had one specific question by an anonymous attendee. They're asking about our opinion on the recent callback seen in the market by established brands. If anybody would like to address this. I have an opinion on it actually, more specifically in the Battery Booster Program. When we were always kept up to date with any recalls that were occurring in the industry, and whenever we saw an item similar to one that was being recalled, we always check the serial number and we check the condition of the equipment. We cross-reference it with the website, the serial number, for example. We cross-reference it with the website. We make sure that the equipment that has been installed is safe. We never found any equipment that was part of a recall specifically, so that's good to see. Fernanda or Chris?
Yeah, I guess just to add to that, I am aware that the industry bodies such as the CEC, the SAA, and the Smart Energy Council are doing a very good job of briefing the industry when these sorts of things happen. Due to the various government rebate schemes such as Queensland Battery Booster, the one in WA, and of course the federal scheme, means that BESS is being installed at scale. So we will find these things as we progress, and it's important that we try to stay up to date on when these things happen so that we can all be aware of it. We can capture these issues and rectify them as soon as possible.
Thank you for that, Chris. Another question, I believe it's from an installer. Will the companies who participated know how they ranked next to each other's?
I would suggest that if the participants in the program are looking for that sort of information, that they would probably have to take it up directly with the Queensland government. It was our job to analyze the data and provide those insights back to the government and here to the industry, but in a de-identified way. Our job is not to elevate or disparage anyone in particular, but just to provide the results. I appreciate it would be probably more interesting to name names. And sometimes we would have liked to have done that, but that's not what we're here to do. We're here to try to provide a objective, unbiased review of the results. But potentially, if you were a direct participant in the program, you could get your rankings from the government directly. We will have a report, finalized report that we're just polishing up now and making beautiful, that will be released Friday week. So that'll be Friday the 24th. We'll post that on our website. That report is de-identified, but the identified report is delivered directly to the Queensland government, and it may be they might make the decision to disclose that information either directly, but we'll leave that to them.
I want to add to that one as well. If you were part of the Battery Booster Program and you want to just get all the reports that you had, but you don't have access to them again, we might be able to send you that again. We still have access to that data. And I would say only if you really need it. We don't want everybody to come back asking for all the reports, but we do have the reports available.
Thank you, Fernanda. There's another question, and also by an anonymous attendee. With respect to seeing issues with a specific manufacturer, do you believe the reason is due to inadequate manuals or installation guides, or due to a lack of supervision, like inexperienced personnel?
Patrick, I think you are actually the best person to answer to that one because you have communicated with manufacturers a lot. In my opinion, there are a lot of manufacturer installation guides that are not great, but usually manufacturers are really easy to contact and they will try their best to help you if you really want to. But a lot of the installers that we realized that they just either did not have access or they had access to a earlier version of the manufacturer data sheet and end up not really paying attention to that specific point. The manufacturer data sheets are often really complex.
Based on what Fernanda is saying, even the best inspectors make some technicians make some mistakes sometimes, and usually we found it's due to not understanding the installation manual properly. So please always double check if you feel like you're doing something wrong. Ask your colleagues, ask the manufacturer, am I doing it correctly? Even if they say, yeah, you're doing it correctly, but at least you checked.
I'm not sure if we can really talk about that yet, but there are some industry-wide EV charging infrastructure inspections that might be coming up.
Yeah,
And so if you-
I'll just read the question. So the anonymous attendee says, this was useful. A similar inspection may be useful for EV charging infrastructure. Is this something GSES thinks will be valuable? Yes, we do. As EV charging proliferates throughout the country, it's probably a good idea that inspections are conducted by the installer or by an independent third party. They are installed in a bit of a different environment than solar and batteries, as they are often publicly accessible, and there might be different issues that occur with the EV charging infrastructure, like getting hit or being around public infrastructure and the public in general. So an inspections program, or at least inspections done by the installer, are highly encouraged.
We have another interesting question. This one is by Ajmal. Any thoughts on any gaps or gray areas identified in applicable standards, for example, AS 5139 or 4777? Within our experience, there are a lot of gaps and a lot of things that can be interpreted many different ways, even though it's just one clause. We do wish it was easier to get clearer answers from industry stakeholders and lawmakers, but we have to work with what we have, and you just have to make sure you're taking into account homeowner safety as much as you can.
Yeah, I would echo what Patrick said. I actually think our standards are quite comprehensive, and to some extent that can make it confusing with regards to interpretation. Just as a corollary, the US uses the NEC, and the bit of the NEC that addresses solar and batteries is quite a lot smaller than the standards in Australia and how we address those two same subjects. And then the onus in the US is put back on the certifying engineer. So our standards are a lot more descriptive and they give you a lot more guidance, but at the same time, it leaves some things up to interpretation. And that's why things like this webinar are good. That's why being part of an industry association is important, because when there are issues, we all get together and we figure it out. And you can see that as the standards have matured, as the industry has matured, we are getting better. And so, yeah, we just all have to be part of that process.
There were a few questions that I think it's interesting to mention about paperwork, compliance list, and CR or inspection list. And we don't have a checklist available ourselves. I don't believe that the CER checklist is available either. But if you go into the Solar Victoria website, their checklist is quite good. It has all the points that we usually check as well. So sometimes it might be program specific, but they have one for solar and one for batteries. And you see there all the documentation laid out, all the signage laid out. So it's good to follow that one.
Yeah, I'd also add to that an inspections checklist is put together, of course, according to the standards that you're referencing, but also according to your workflow. And the workflow that we have used with our inspectors might not be the best workflow to suit yourself. As an example, though, if you were to enroll in the GSES inspections course, there are some excerpts of battery checklists that you can reference, and that might be helpful to you.
Thanks for that, Chris. There's another interesting question. Was the lack of RCDs on backup circuits a common issue during the inspections? It wasn't a very common issue, but we did find quite a few, and we did have to call them unsafe. I could say off the top of my head, probably about 10 of the unsafes that were found were related to this.
There is a question about similar rollouts happening for other states. The ones that we know about, the federal one, so CR federal one, that one is everywhere. We know that WA is doing some inspections as well. But yeah, I think that's all we have for now. Batteries everywhere though.
Just a fun one. Got a anonymous attendee saying, "What's the weather like in Queensland?" Generally, it's lovely. We encourage you to visit. Patrick, do you have another one for us?
We are getting a lot of questions, especially towards the end. Since solar PV systems do pose safety risks in non-compliant installations, do you think Queensland government or federal level bodies may mandate compulsory inspections for solar PV systems and battery systems on a recurring interval every year or every 2 years?
I think that we're a bit biased in this regard. However, in saying that and disclosing that, the data here does reveal that the inspections are incredibly important for the industry uplift. I mean, we just showed that, or Fernanda showed the Sankey diagram, which I feel like is our hero diagram, showing the uplift that occurs when we engage directly with installers. So when we do have findings, generally speaking, the installers will take our recommendations, return to site and make rectifications and then report back to us. And hopefully it's not surprising to anyone, but I will say that the engagement that we had with the installers was almost completely positive. I think of the 2,773 inspections that we conducted, we only had issue with one or two installers with regards to making rectifications. Largely, it was a very positive experience on both ends and with regards to the homeowner. So I think an inspections program is critical. We know that the CER is doing inspections on a percentage of installations. Of course, we'd like to see more, and potentially that will move into the hands of each state as more and more installations continue to happen and more states continue to provide incentive schemes. So I think the short answer is yes, we'd like to see more, and hopefully we will.
I'd like to answer Thomas Samuel's question. Hey, Thomas. The labeling of alternative supply circuits a common non-compliance on the program, absolutely it was. So we did have people that would put the correct backup supply label and the backup label on the correct breaker and so on. And I do believe that that's going to be even a bigger compliance issue now with the changes on 4777. So this program, all the installations were done under the previous 4777, and now we have done just a couple of inspections on your systems, and we are already seeing how difficult it's been to really get the correct breaker label in the correct circuit breaker. So we're going to see a lot of issues on this one.
I've got one more. Were there many issues identified relating to the DC connectors not being connected appropriately? You might be recalling in our presentation, we did show an ELV connector that was burnt and to the point where it had separated. So yes, that was one of the issues, and that's why one of the unsafes occurred. But I thought this was a good question because we did also find in a few instances the cable was rated improperly. So that is not necessarily an installation issue, but a design issue. And inappropriately rated cable used is unsafe. So it's really important that you get the installation correct, but also the design of the system correct. And that's something that you can work on with an engineering team, or you can use the appropriate design tools. But again, that sort of harkens back to the review of AS3000, and in this case, AS3008.
And for those of you who are asking about label guidelines and checklists and best practices stuff, we don't have a one guide, but we do have quite a few CPD courses that talk about these things. And we have a pretty good blog that has a lot of different technical articles, all free for you to look at, that explain a lot of the details. So for habitable rooms, changes on 5033, changes on 4777, all the different unsafe things that we found with battery booster that were really critical, earthing of the system, all of that is in our blog. I will send a little link. I don't know if I can send to everyone, but I can send to one person. So I'll send to Mehdi. Here I'll type on your answer about our update to signage on 4777. That should give you some help. But you can have a look at the blog.
I think we might leave it there for now. However, I will invite all the attendees to, if you do have any further questions or if your question wasn't answered, please reach out directly to us. You can either write to info@gses.com.au or consultancy@gses.com.au, or you can call us anytime. We're happy to take your questions. This was a real privilege to be able to present this information. It was a privilege for us to provide the inspections to the Queensland government. And thank you all for taking the time today to come and listen to us. As we mentioned before, this presentation will be made available on our YouTube channel, as well as on our socials, and we'll post that as soon as possible. Fernanda, do you have any closing comments?
I think my main comment is to thank the Queensland government for having done this amazing program. It was really a groundbreaking program where so many batteries got installed and 100% rating of inspections sounded crazy at first. And I'm really glad that we got there and we actually did close to that. And we are always open to help with education, so we'll try our best to answer your questions always, to have a look at our website, including our blog. And there is a lot of discussion to be had about all these topics. And we will be walking around in All Energy 2 weeks from now. So if you see one of us with our black shirts with the green little logo, or with the red little logo, sorry, we'll be happy to have a chat as well.
Thanks, Fernanda. And thanks, everybody. Have a good
Thanks,
rest of your
everybody.
afternoon.